Welcome to Chapter 4 of the Shapley Values series. In this chapter, we finally talk about Shapley values themselves and why they are a powerful explainability model. Let's dive right in. In literature, there exist quite a few explainability models, such as LIME, DeepLIFT, or Shapley value estimation. We will focus on Shapley value estimation, as only this method fulfills 4 desirable properties for an explainability model. That means we will from now on refer to phi sub I and phi sub 0 as Shapley values, because we will use Shapley value estimation to derive them. Let's imagine the explainability model looks like this. Then the values for the feature's importance, for example 6.25 for price, or -4 for temperature, are then considered Shapley values. Before we dive into how they are calculated, let's discuss the Shapley values' desirable properties that make them such a good choice for an explainability model. Firstly, Shapley values are efficient. That means that all the individual feature values, that is, the feature's Shapley values, add up to the forecast. Note that all the feature values are expressed in units of the forecast, which makes them easily interpretable. Secondly, Shapley values are symmetrical, which means that two features that have exactly the same effect will receive the same Shapley value. Thirdly, a feature that is considered a null player, that is, it doesn't have any influence on the forecast, will always receive a Shapley value of 0. Lastly, Shapley values are additive, which is a more theoretical concept that expresses that if we were to break our forecast into two different forecasts, then the Shapley values for each of them would add up to the correct Shapley value. We have now learned that Shapley value estimation is a popular explainability model, as it is the only known method that fulfills these 4 desirable properties.